Hi friends, one more equation we can balance now. The equation is sodium hydroxide, the reaction between sodium hydroxide and sulfuric acid. When sodium hydroxide reacts with sulfuric acid, sodium sulphate and water are obtained as a product. Let's balance this equation now. First of all, we need to list out the atoms present on the reactant side as well as the product side. So what are the atoms present in sodium hydroxide? Sodium. This sodium atom, we can write it here, sodium. The next, what is that? The next, instead of this oxygen, hydrogen, we can come to the next reactant. Here, in sulfuric acid, sulphate radical is present in sulfuric acid. The same sulphate radical is present in sodium sulphate also. So in a chemical equation, if the same radical is present on both the sides of the chemical equation, we need not break the radical into different atoms. Instead, we can consider that radical as one unit while we are balancing. So now we can write this sulphate as one unit. We need not break it. This is one unit. This together we can consider one atom like that. That is one unit. Next, what is left out? Here in sulfuric acid, hydrogen is left out. So that hydrogen we can write. Next, what is left out? Oxygen. In sulphate, oxygen is there. That oxygen we are not taking into account. That is separate. Sulphate radical. So this oxygen we need to count once again. That is, so we need to write here oxygen. So after writing this, what we can do, left hand side, how many sodium atoms are there? Only one atom. Left hand side, only one sodium atom is present. The right hand side, how many sodium atoms are present? After the sodium, the subscript 2 is there. This 2. So sodium at the right hand side, 2 atoms. Now sulphate radical at the left hand side, how many times it is there? That is only one time, because after sulphates radical there is no subscript. Therefore sulphate at the left hand side only once. Sulphate radical at the right hand side also, it is only once, because there is no other subscript, so only one radical. Now hydrogen at the left hand side, hydrogen is present at 2 different places at the left hand side. Here it is 2 times, but here it is only 1 time. So that we can write it. So at one place it is 1 time, here it is only once, but here this is 2 times. Oxygen at the left hand side, which oxygen we need to count? This oxygen alone. This oxygen can we count? No, because it was already counted in sulphate radical. So this oxygen, how many times are there? Only 1 time. Now the right hand side, sulphate at the right hand side, Only one. That already we have mentioned. Hydrogen at the right hand side. Where is hydrogen present? In water. That is 2 times. So that we can write it here. 2 times hydrogen. The next one is oxygen. How many times oxygen at the right hand side? Only one. Only one time, only present. This oxygen already we have counted in sulfate radical. Therefore, we should not count now. Now we have listed out. Now we can check which atoms are not equal on both the sides of the equation. Which atom is not equal? The first one, sodium. At the right hand side, 2 sodium atoms, but the left hand side, only 1 sodium atom. So what we can do, that 1 we can make into 2 by multiplying by 2. This 2 we need to write as a coefficient of this sodium hydroxide. So this 2 we have written as a coefficient before this Na. That is before this sodium hydroxide formula. So when we write this 2 belongs to sodium, oxygen as well as hydrogen. Therefore oxygen atom will change at the left hand side, hydrogen atom also will change. So now we can count how many hydrogen at the left hand side. Already here 2, here also 2. This we have mentioned previously. At one side 2, this 2 we have mentioned, and this side only 1 already. So now this becomes 2. So hydrogen already 2, now another 2. So total this 2 plus 2, how many? 4 atoms. But the right hand side hydrogen, how many atoms are there? Only 2 atoms. Therefore this 2 we need to multiply by 2. This 2 we need to write as a coefficient of hydrogen. So before this hydrogen, we need to write this 2. So when we write this 2 as a coefficient, this 2 belongs to both the hydrogen as well as oxygen. Therefore, now oxygen has changed at the right hand side. So oxygen has now become, oxygen has changed into, what is that? 2 times at the right hand side. So this 1 we need to change into 2 because this 2 belongs to oxygen also. So 2 times oxygen. But the left hand side, how many oxygen atoms are there? Only 1. Therefore what we need to do? No, this 1 already it was made into 2, because while we are multiplying by 2, the sodium by 2, this oxygen already it was changed into 2. This was already changed into 2. Now we can check both the sides of the chemical equation. Sodium, how many atoms are there on both the sides? 2 atoms. Sulphate, how many radicals are there at both the sides? Only 1 radical. Hydrogen, how many times both the sides? 4 atoms, here also 4 atoms. Oxygen, 2 atoms, 2 atoms. So all the atoms of the elements on the reactant side and the product side are equal. Therefore, now the equation is balanced. So the balanced chemical equation is 2 moles of sodium hydroxide plus 1 mole of sulfuric acid. As a result, 1 mole of sodium sulphate and 2 moles of water are obtained. Thank you.